So with that, let's get started with the actual item that I anticipated spending the time on this today. It's our usual practice now, just the problem solving with the ChatGPT 01. And I think this week's material will be a little bit more interesting. Last week was a special relativity intro, and some of it was a little bit cut and dry or very simple in some sense. And now with the full introduction of Lorentz transformation, we can do more interesting scenarios. But it will still be the case that a lot of the questions here, which are from the textbook questions, they are so in some sense the coverage in the lecture is at a higher level in the sense of more complexity, more interesting scenarios covered compared to what your textbook does. That's really one. I don't know. One complaint is probably too big of a word, but one thing I'm not quite satisfied with the most lower division physics textbooks. Actually, it takes a textbook that's kind of specifically written with the modern physics in mind to have questions that properly exercise your knowledge of modern physics topics. But in any case, Lorentz transformation is still fuller set of topics, so I think there's going to be more interesting things to look at here. So let me bring up ChatGPT, and I think I've done this before, but let me just do it again as a reminder. So really the main value of ChatGPT is that it's an interactive virtual tutor. And unless you take the care that I ask you to take, it's not going to be a good virtual tutor. For example, if you simply copy and paste in questions, then it'll just answer the whole thing. And, if you wanted the answer, you don't need a ChatGPT. You got my homework helper videos. I did show you all the formulas. Now the numbers will be different. So I guess with the ChatGPT, you can do even less work. But in terms of what's beneficial for your learning, don't do this because it won't help you learn. Like right now, I'm just copying and pasting, and I, who know all this physics, have no idea where this number came from. Let me actually read it. What's this? This might be actually Galilean relativity portion of the question. I think Yeah. So for this question, you're trying Galilean relativity works fine because these p's are so small. Yeah, that's what this is. And then the next question is special relativity. But before I waste more questions, actually, I wonder. Let me ask you this anyway. I'm actually curious how ChatGPT will do. Just out of curiosity. After that, I'll start the proper the virtual tutoring session with the ChatGPT. So here, according to Galilean relativity, it should be 1.31. See, I think. Yeah, and special relativity. There's some formula. Yeah, that looks like the right formula. And so D, you can just guess the correct answer because questions like this answer is always a C. So last year, before Galilean predict. Oh, right, yeah, it's not 2. It's 1.86. Good. So last year, with I guess it wasn't even ChatGPT 4.1. I think it might have been just ChatGPT 4, and it did struggle when we got to modern physics. And with the newest version of ChatGPT, I'm actually curious how well it does in modern physics. But anyways, so this is not how you should be using ChatGPT if you're trying to use it as a tutor. Because even so, what I was doing, just copying the numbers, that definitely doesn't teach you anything. And even if you were carefully reading through these answers and you feel like you understood when you read it, let's say you read it through this and you feel like you understood it, oh yeah, velocity transformation, that's what you get. Now imagine this scenario. We do our one-on-one meeting and I ask you this question and I ask you, can you show me your work for this? And you can't use your notes. And I guess if you tell me that there's a special relativistic velocity transformation law and you need to know that, then I will probably write it down. But let's imagine I'm in a really foul mood and I refuse to write it down for you. I just say, here's the textbook, you can use it. And having just used this, it's possible that you might not know where in the textbook to find the transformation formula. So this is what I mean. When you are using ChatGPT in this way, it doesn't quite help you as much as you think at the moment it does. Because you need to think through, you need to spend some effort, you need to really struggle with the question. Now, these first two questions are easy questions, so maybe you are not really going to be struggling with those. That's fine. But the later questions, the more substantial questions, really a big chunk of learning is struggling with the content. And as you struggle, you might actually work through them fine. Then you didn't need my homework help video. You didn't need ChatGPT. That's really what learning is. And if you get stuck, then one of the reasons I provide the homework help video is to help you. You can see a version of someone working out the question that's correct. And if that helps you, great. I remember many discussion session when I was in university, upper division classes. Big chunk of time was spent with the TA, just working out the homework questions. And some of the student questions are basically, could you work this out for us? And there's some value to that, just seeing the material for the first time that way. And I think for you to better retain and better remember, you do really need to interact with the material yourself. So here, let me stop doing the thing that I shouldn't be doing and let me tell ChatGPT to actually help me. So thank you for this. But I should have said this at the start. I'm working on these special relativity questions in preparation for the one-on-one meeting with my instructor next week, and I do really need to learn to do the questions myself. So would you please not give the full answer right away for the rest of this session? Really, for each question, I'll try to tell you what I've tried and where I got stuck. Where I think I got stuck. Just to help me with that part, please. Once you give ChatGPT the proper instruction, asking not to be given the full solution, which all the other human beings prefer. Once you tell it that, then it'll adjust its approach. So let me find the substantial question and ask it that substantial question. This, I don't know, velocity transformation questions feel easy to me because just plugging in numbers into formulas. I wonder if there's a mistake I can make while I plug in the numbers into the formulas. I don't know. Let me go looking for a more substantial question that I like better. Planets on a collision course. This is still relative velocity question, I think. Why are there so many relative velocity questions? Which is weird because I think in the lecture I specifically don't lecture on relative velocity. I just tell you, look up the formulas in the textbook. Because it's a it doesn't fit nicely into four vector formalism. Oh, I think this. So let me just. Um, I think questions 4 and 5 are similar. In that, I don't think it's directly using relative velocity formula. Let me see if I can try to sketch it out to see if I correctly understand what they are saying. So two things moving towards each other. I think I can misunderstand the question. So I believe what the question means is if I imagine one being at rest, it means to say the other is moving at this speed. I think that's the correct interpretation. But maybe I misunderstood. Maybe I made it more complicated for myself and instead thought they are, heading directly toward each other. And somehow I'm imagining a third observer that's in the center of mass frame, seeing both of them moving at speeds 0.245 c. And based on this misunderstanding, let me work through the rest of the question, which ought to be wrong. So let me move this a little bit farther out so I have more space between them. And let's say one of them sends a spaceship. And sends it from one planet, approaches the second at 0.715 c, as seen by the second planet. I don't know. I don't have a proper notation for this. What is the velocity of the ship relative to the first planet? All right. So I guess let's have the frames set up. So based on my misunderstanding of the setup, I will have 3 frames set up. So I'm going to call this frame S. This is a frame S speed. I'm going to call my observer, like observer looking at, let me do a different color. Oh, actually, I guess green would be the color to use. Observer looking at all this. I'll call that frame S prime. That's the speed, speed of the planet. That's in frame S. And then I'm going to misunderstand this velocity to be for frame S prime, double prime. And that would be the reference frame of this this planet, which will be at v equals 0 in S double prime. So I'm going to do 2 velocity transformations. So I have speed v of the spaceship, which as seen by this planet is 0.715 c. And to transform it, okay, so okay, for the question I'm working on now, I need the relativistic velocity transformation formula. Could you give me the formula for frame S to frame S velocity to frame S prime, velocity, parallel to the Lorentz boost direction. I know where to look it in the textbook, but I thought this would be faster. With all this typing, it probably isn't. It's less annoying than switching windows. In fact, I did look it up before, but I think I closed it. So I need from that relative the velocity transformation formula. I'm going to write down the spaceship velocity in the primed frame. First, the primed frame, and as soon why is it taking so long? And just giving me a formula. Can I remember it? It's I want to say V minus U divided by 1 minus V times U divided by C squared, maybe. Let me proceed based on the sign here on the numerator. It basically depends on the direction. Here I'm expecting the V prime value to be less. And here, so U would be 0.245 C. That's the relative velocity between my S prime frame and the S frame. And yeah, this will give me a slower speed, so all of that's fine. It does worry me that ChatGPT is not giving me an answer right now. Sometimes it gets stuck, especially when a context window gets too long. Oh, okay. Oops, wrong color. And to label this with the blue. Yeah, I remember the right. Close enough. Yeah, I'm using V and U differently than ChatGPT. It's fine. So let me do this calculation on a calculator. So I'm gonna do 0.715 minus 0.245 is equal to that, divide by parenthesis 1 minus, I think minus is right. I think it's right. 0.715 times 0.245. So that's equal to 0.5698. So it's equal to 0.5698 C. And I do believe that's actually the correct answer to what the question is asking. But with the misunderstanding I have had about how the planets were set up, let's say I think I still need to transform it one more time to get the speed of the spaceship in this reference frame, one that's moving, planet that's moving to the right. So it's actually the exact same shift, just done one more time from the reference frame, I mean. Double prime is equal to same thing, V prime minus U divided by 1 minus V prime times U divided by C squared. So doing that calculation now, so I'm gonna take this, store this into memory, minus 0.245 divided by 1 minus memory recall times 0.245 is equal to 0.3775. 0.3775 C. And let's get a response that says it's wrong, and then let's complain to ChatGPT. Yeah, it says it's wrong. I correctly misunderstood the question the way I meant to. Okay, I'm really lost. I think I applied the formula correctly and each system made sense, but the system says my answer's wrong. And ChatGPT might be able to read through the question and tell me that I did the extra frame shift that wasn't necessary. Or not. I don't know. It's been hit or miss if ChatGPT correctly gets the gist of what it is I'm trying to do in my mistaken work. Sometimes it kind of saw it. Sometimes it didn't. Sometimes it just gave me a description of a common error that didn't necessarily actually relate to what happened. Very explicitly frame as okay. Um, So I think reading this description, you should be able to see that how ChatGPT's understanding this question is different from yours. So after you understand it, I could have, wait, you are dealing with only two reference frames. I thought there were three. The reference frame S prime where the two planets are moving toward each other, each at 0.245 C. The reference frame of each planet, S for the planet on right, and S double prime for the planet on left. And I don't know if it'll try to convince me or it'll say, "Oh, my bad. Here are answers with the three reference frames." I don't know. I think one fault of ChatGPT is that it's too agreeable. Because that's what it's the pre-trainer people prefer. Like nobody wants something disagreeing with them. Can look like a three frames at first glance. Which was the purpose of only need two frames. Yeah, I don't think it kind of got the gist of the mistake I'm making. Mainly that I misread the question. Like it comes down to a meaning of this sentence. Like, is it like what I pictured here, or is it just describing from perspective one of the two planets, meaning the planet? It's like, yeah, I don't know. So this one, I would say miss. It didn't quite fully get the mistake I was making and didn't correct the mistake. I don't know. It's just a work in progress, right? So I'll just say, um, um, I read the question again, and I think I misunderstood the setup. I didn't need to do the Lorentz transformation twice. Just once gave me the brain thing. Or uh, I'll do that and then move on. There are other more interesting questions. Let me look for a question that doesn't involve velocity transformation. I think there are questions that involve relativity of simultaneity. So let me get to those questions. Yeah, this is the again that. Oh, I think that's enough for the session we have today. Yeah, the common mistake. In fact, if you use a third frame, that'll make the question way more complicated. Because if you're thinking of a center of mass frame, like center of mass frame, these planets are not moving at half this speed because it's just overcomplicating things. In fact, in special relativity, one of the things to watch out for is when trying to look for the kind of simplest possible way to solve something. Because sometimes there are ways where you can kind of get jammed up in algebraically difficult to set up. And sometimes there's like calculational trick, other simpler way of approaching it. You will see more of that next week when you do relativistic dynamics. And I do give you some hints and mathematical techniques. So I think this is one of the questions that involve relativity or simultaneity. Let me read, work through, and look for opportunities to mess up. Spaceship is moving at that speed. Select another spaceship B, set their clocks. Okay, that's just origin of the coordinate. Observe at the origin B, turns on the laser at t equals 0, turns it off at tau for proper time. What is the time duration between on and off as observed by an observer? So here's a mistake that's easy to make by someone who's overthinking the setup and who doesn't use the way we use the word observe in our class. So I can imagine someone doing this. Someone who's overthinking the setup, where you have, let's say this is the spaceship that's going to be at rest. And spaceship A is, same frame. Let's at time equals 0 this way, and then it's moving to right at speed of v equals 0.5 c. So, and I'm not using space-time diagram because someone who's using space-time diagram won't be making the mistake that I'm gonna make. So, at t equals 0, the light turns on. At t equals 0, and then goes off at t equals tau. So I imagine this frame having moved for a distance of t is equal to v times tau when it's turned off. And then I'm looking at this light traveling from here to basically catching up with the observer who's traveling. And let's say I say at the time here, so at some distance x equals t final times c, the light catches up with this observer. And that's one description of x. Actually, sorry. For light, I would have to describe it as the speed c times the duration of time would be t final minus tau. Because the kind of the final bits of light that's arriving here, it waited for time tau. And I compare that, so that's x light, compare that with x observer, and say, well, this person traveled at speed v for just the entire time t final, from the start all the way to the end. And here, at the time when the light catches up, I set these two expressions equal to each other, and then I solve for what is t final. So let's say I'm doing that. I solve for t final is equal to, just doing some of the algebra in my head. It's gonna be tau divided by c minus v, I think. I'm imagining setting this equal to each other, moving v times t final to the left, tau to the right, tau is to the right. On the left-hand side, I had a CTF plus, minus v. I factored out TF and then divide both sides, c minus v, to get this. So, with all that, now this is a mistake in two different ways. One, I think you will notice that I didn't use special relativity at all here. This is like some sort of Galilean calculation. So that's one, just conceptually speaking. And two, this is not what they were asking for. This is the kind of the scenario that someone who's not versed in special relativity might imagine. Where someone thinks, oh, this whole time dilation thing, it's just the signal delay time of light. That's what someone could think, and it's not. So I guess let me just finish writing down. So we know the numerical value of V. We know V is equal to 0.5 C. So plugging this in, I think it gives a T final of 2 tau. Because c minus 0.5 c, or 2 t tau divided by c. Or did I miss something? There was actually c times tau here, so divided by c, so that actually cancels out c, so that's fine. So 2 tau is what we are looking at. So when I say that t tau 2 times tau, it should tell me it's wrong. Wrong for quite obvious reason that what I did is not special relativity. Let me see if ChatGPT can help us spot this mistake. It's possible that it won't. Because I don't know. I have a multi-part question, and I'm working on part A right now. The question is for duration of on and off event for a moving observer. And I try to work at the time difference between when the moving observer will see the on and off events. See diagram on top. I hope it makes sense. But the answer I found is wrong. Can you help? It might just start giving me the time dilation formula, which might not be, which might be nothing, because it's a different answer that you can try. Okay. Oh yeah, so this is good advice. Don't do this complicated stuff. Okay, in a frame must be scaled by the same factor you use for time dilation. So I'll say by Lorentz factor, you mean gamma equal to 1 over square root of 1 minus v squared over c squared. So this might be enough of encouragement to just try it, and then what have you got to lose? You already missed the ones. So you just calculate the gamma factor. So 1 divided by parenthesis open, 1 minus 0.5, that's v over c squared. And then when I press the square root, it'll make that square root. Yeah, say equals. I get 1.155. So 1.155. And so the ChatGPT won't know the special way in which we use the word observe. It's not quite standard enough. David Griffith is a popular author, and it's his convention, but it's not a universal convention to use the word observe to mean like if you are using a magic telescope, account for the signal delay time and all that. But I think yeah, this is fine. What are you? No, that's correct. Let me work on the other parts. Let me see what other mistakes I can make in the other parts. All right, B, rod of length 1 meters laid out. What is the... So let's ask. So for this, do I just use length contraction formula? So for this part, do I just use the length contraction formula and formula? It should say yes. So let me do that. I can do 1 divided by 1.115, 155, 0.866. All right. There ought to be some opportunity to make a mistake. Consider two events occurring in spaceship B. B is the one that's not moving. A photon arrives at the origin at time t equals 0, and another photon arrives simultaneously. As measured by observing frame A, how far are those two events separated in space? So here's a mistake that someone could make. Not paying attention to this careful description and maybe thinking, A was a lot simpler than I thought it was. B is a simple length of contraction. So why not another application of length of contraction? A is moving relative to B, therefore B length should be length contracted to A. In fact, I mean, it's basically this. So you could be thinking C and B are the basically same question twice. This worded in a complicated way. Then you miss it. So I thought the next... Okay, this was correct, but I thought the next part was the same thing, but the system says it's wrong. Why does length contraction apply again? And ChatGPT will probably explain that the description says it's set up to be simultaneous in frame B, and in frame A, it's not going to be simultaneous due to Lorentz transformation or relativity of simultaneity. Yeah, classical relativity of simultaneity trap. Two evaluations are simultaneous B, but not A. Yeah, length contraction applies when you measure the same time in the measuring frame. So in part C, in A, you just work out their distance as they're not simultaneous. So you need to do full Lorentz contraction. Yeah. And actually, when you do that, this is all a great explanation. And I recommend that you do the full Lorentz transformation. when you do that, you will get this. Basically, because the way time component transforms is symmetric to the way space component transforms, so it'll be just 1 point, multiplied by gamma instead of dividing by gamma. And I think the rest of the question kind of reconciles that difference. So considering the same two events in C, how far are the two events separated in time? Yeah. So this you actually need to use Lorentz transformation to get. So yeah. Um, I want to work out the numbers. So let me ask a ChatGPT for it. Uh, uh, okay, I got see. So this part I don't quite recommend as much, but uh, for the I got the Lorentz transformation, but I don't have a lot of space to write. Can you help me write the time difference in seconds in 10 to minus 8 seconds? And hopefully it'll give all the details. So when you write that, CT prime is equal to gamma CT minus beta x, so the x is gonna be delta x is gonna be 1 meters. So CT will be 0. So it'll be, I think, gamma times, yeah. So looking at that, T prime is 0 for both events. So yeah, difference comes from that. And gamma, so beta 0.5. So 1 over, all right, I don't have the number memorized, but looks about right. C being 3, 1 divided by 3, yeah, that looks about right. That works out to be about, yeah, that's probably right. Yeah. Yeah. Yeah, again, this is the one part where I would have written up, but I want to save enough time to do one other question. That's why I'm not doing this myself. That's my excuse. How far does the spaceship move? So this is the thing that you can work out. Um, so I think I have enough already. So in the amount of time here, 0.19 times 10 to the power of minus 8. That's the amount of time. You multiply that by speed, which will be 0.5 c. So 0.5 times 3 times 10 to the power of 8 meter per second. So that's how far spaceship moves in that time. It moves 0.285 meters. And I guess there really should have been part F that makes you reconcile everything. So the spatial separation that spaceship A measures, it is basically the length of contracted distance, the length of the ruler, 0.866, plus how much the thing moved between those two events. So this plus 0.866 gives you this spatial separation with some rounding errors. I think most of it's coming from here. So that's the kind of point of this question, and it's meant to kind of show you that the kind of the full explanation of why you get a contraction, and that it's all consistent with the gamma being in the numerator for both parts of the Lorentz transformation. Thank you. I got it. All right, let's look for one other question to do. I think this was the main question I was thinking of, but there must be at least one other question that's interesting enough to do. And there's this. It's basically same as question 6, but with a less explanation. Fewer parts. I might come back to this if there is a better question later. Oh, this is an interesting question. So let me play a little bit dumb and let me check questions 9 and 10, and then yeah, they're not all that different. Or I think question 10 and 8 are similar. Let me do 10 just because that's more spacey. So I will feign confusion. I'm a little confused by this question. I thought moving of servers couldn't uh, see simultaneous events. Why is the question asking me uh, how to how how fast to move the spaceship to make something that wasn't simultaneous? And it should be saying basically use the Lorentz transformation, ignoring your intuition, and don't get trapped into the whole canard about how. I did a lecture on one errata example where someone thought like a telling events simultaneous had something to do with the claim about being at rest, which is nonsense. Just use Lorentz transformation. Yeah, makes sense. To remember, it depends on your. Yeah, yeah, yeah. So if they are simultaneous in one frame, then they will not be. But yeah, flip side is true, which means if they're not simultaneous, as long as they have a space-like separation, you can make them simultaneous by going into the right reference frame. Um, yeah, yeah. Mathematically, you set the Lorentz transform time difference 0 and solve for V. Yeah. So let me give that a try and see if there's a place where I can make a mistake. So I start by writing down Lorentz transformation. Ct prime is equal to gamma Ct minus beta x. And do I need to write down more? Maybe I just need this. Yeah, I don't think, I mean, I can write down x prime is equal to gamma x minus beta Ct, but I don't think I make use of this at all. So following ChatGPT's advice, I'm setting this equal to 0 to make the time difference in the moving frame. The spacecraft is at prime frame, that's 0. Then whatever gamma is, it doesn't matter. I just need to set this equal to 0. So solving for beta, um, that would say beta is equal to oh, I guess this is the place where I can make a mistake. So beta ought to be equal to Ct divided by x. I'll say x divided by Ct instead. So x is 2 times, so 2 times 10 to the 9 meters divided by, so 3 times 10 to the 8 meters per second times 0.3 seconds. So the whole thing has unit of meters. So I calculate this out. Well, I think the first hint it should be, I made a mistake, is beta here will come out to be bigger than 1, which, is unphysical. That ought to be your first hint that there was a mistake. But let's imagine, or you realize, oh, that's a mistake, and I can't figure out my algebra mistake and ask ChatGPT. So you get beta is equal to 22.22, which again um, let let's say whoever's doing this didn't have good enough intuition and didn't realize immediately that that's wrong. I'll just plug that in. 22.22. Just not think through, hey, 20 times speed of light, that makes no sense. Uh, and I'll ask Okay, I did that. Did I do something wrong? It says my answer of 22.22 is wrong. I wonder if ChatGPT will also point out that any number bigger than 1 is unphysical. I'd be impressed if it figures out my algebra mistake. This handwriting stuff, it's been hit or miss if it follows my steps. Some of it could be just, disorganization in how it's written. But finish the reasoning, and then it got so frustrated with me that it refused to say anything more. I'm running out of responses. Do I try again? Oh, I wonder if O3 will work. Maybe. So before O3 Mini wasn't available when you used images, but if it still works with the images, I mean that's must be a new capability added in the last couple of weeks. Yeah. So it is. Um, so, but I think by the time you get to this, then you will realize, oh, I made an algebra mistake. So I'm pretty sure this is coming from the fact that it's reading top to bottom. So it's not reading these arrows, which is going backward. Uh, yeah, that's not the reason, but oh, it didn't just start with a beta. It goes city, but I do see my mistake. I made an algebra error. I should have the beta is equal to ct over x. So let me calculate 1 over 22.222 and get 0.045. 0.045. Yeah, but it has nothing to do with the factor of c. It's I think that's it. All right. Thank you so much. So yeah, it's yeah. So I feel like it's gotten a lot better with the modern physics. Again, a year ago, I probably wouldn't have trusted ChatGPT to act as a virtual tutor, especially with the physics 4C, because with the modern physics, I thought its rate of error was too high. But I imagine so. There was a conceptual question that I used to ask that I don't ask this semester, but there's a one about describing twin paradox, from the perspective of the traveling twin. And last year, ChatGPT didn't answer that one correctly, but this year, with the latest model, it wouldn't surprise me if it gets that fully correctly. So, anyways, thank you so much. I think that's all the time we have. Thank you to those who are joining in real time and those who may be joining by recorded video. Let me say goodbye to people joining by recorded video, by which I'm gonna stop the recording and I'll stay online briefly in case our real time participants had any question. So bye to people joining by recorded video.